things that'll be on your chapter 6 test. We're going to do derivatives of log stuff. Okay, so these are derivatives, not antiderivatives. And we'll also do integrals involving partial fraction decomposition, which we had last year, but you probably forgot. Alright, so just doing the derivative stuff, if we found the derivative of this, you would have to do 1 over x squared sine x, but then you'd have to do times the derivative of x squared sine x, which would involve a product rule. So we could find the derivative of this as it is, but it'd be easier to just change it using our log properties. So we could rewrite that as the natural log of x squared plus the natural log of sine x. Okay, so now we could just do y prime would be 1 over x squared times 2x, 1 over sine x times cosine x, so it's 2 over x plus cotangent x. Since we rewrote it using our log properties, it becomes a very simple derivative. Yep.
Could you just put the 2 in front of that?
Yep, that's another way we could have done it. Yep, and you would have gotten the same thing. Okay, so that's the whole derivatives of log I wanted to show you. And there's a sheet of that. That'll get you most of that stuff. That sheet. It looked like there's some implicit differentiation toward the bottom. That'd be good review for you. And if you have, like, I feel like there's this type of problem on there. How do I do this derivative?
A substitution?
Oh.
Wait, oh, this is...
It's not an a to the u because it's a to the u is a constant base, and this is a variable base and a variable exponent. Anybody remember how to do this?
Logarithm.
Good. We'd have to take the natural log of each side.
That is what the lesson's about, so. Copy that.
So then we could do what Angela was saying, bring the exponent down. And we're ready to differentiate. So 1 over y, remember y prime because it's a derivative of y with respect to x. And then product rule and so on. You want me to finish it?
Yes.
Okay. So sine x times the derivative of natural log of x. Then multiply by y, which I'll just leave it as y for right now. And then we could say what y is. So it's just x to the sine x times all of that stuff. So you do that technique if it's a variable to a variable. I thought I saw at least one of those on that sheet. Okay, so that's log derivatives. Now we're going to do integral stuff. Let's say we're going to integrate 2x plus 3 over x squared minus 4x minus 21 dx.
Logarithm.
It worked last time, didn't it?
Does it work this time?
No. Well, we'll need logarithms at some point in this problem.
Yay.
But that's not step 1.
Partial.
All right. Partial fractions, yes. So we can't use u substitution here because you'll get 2x minus 4, and we actually, you could do substitute. Let's say this is 4 actually.
Gotcha.
But I'm not going to show you because, well, you get 2x minus 4, and that's 2x plus 3, so we're close to a u substitution. We'd have to manipulate it, and we're not doing that this year. That's a BC topic.
Solve for
So
x.
I could not do u substitution here because you'd end up getting derivative 2x minus 4, and I've got 4x, and it gets messy. So we have to rewrite this in terms of partial fractions. All right. So the whole 4x over x squared minus 4x minus 21.
What happened to the 3?
Yeah, it's gone.
It's there.
Okay. Constants do matter. Cherry flavor.
Okay, so this factors to be x minus 7, x plus 3. Somebody said factor. So it has 2 factors. So I'm going to assign A on top of the first factor and B on top of the second factor. Looking familiar at all?
Yeah, AB are the initials of Monica.
Good to know. Okay, so we are going to multiply both sides by whatever this bottom factor is to be, or times the bottom. So we're going to multiply both sides by x minus 7 times x plus 3.
Can you explain
Both-
how you factored that?
Diamond problem?
Yeah. Can you explain how?
Yeah,
See your algebra, see your algebra teacher 4 years ago.
I don't
Okay,
know.
so if I distribute on the left side, what will I have left?
Just the top.
Good, 4x plus 3. And if I distribute it to here, the x minus 7s will cross off, so it's a times x plus 3, and then b times x minus 7. Are you with me?
Yes.
Alright, so Alright, so what we need to do now, since we don't have any quadratic terms, we just have linear terms and constant terms, we can make two equations. So the x's, I have 4 on the left, and I have a plus b on the right. Grown.
Can you explain that?
The constants on the left, I have 3 of them,
Pound symbol.
and I have 3a minus 7b.
And then you can.
Solve the system of equations, yes.
Hey, that's like 8th grade.
Okay, so if you're lazy enough to just use this in matrix, do you know how to do this on matrix?
No.
Go ahead.
How's that?
Doing it.
If you want to do
That goal was here
elimination,
for a reason.
so a 2 variable, 2 equation, you're probably going to be able to either use substitution or elimination pretty easily. Sometimes you'll have a 3 by 4 down here, so 3 equations, 3 unknowns. I would encourage you to do the matrix.
Becco did not come here for no
So
reason.
it's 1, 1, 4, 3, negative 7, 3, reduce row echelon. Remember that stuff?
Yep, it's just a weird abbreviation for
It
something.
hit math, well, hit the frac button, and it'll give you the fractional answers.
Oh.
You got that didn't solve anything
Do
actually.
the second half.
I forgot how to do that actually. Becco did come here.
Ah,
Alright,
that's wrong.
human wins the race.
Hey, that's not fair.
We had to find where it was.
Still human versus human.
You just have calculators.
Where is the, how do you calculate the matrix?
So did you calculate, edit, and create?
I made the matrix.
Okay, so
Go
now
to
exit
math.
out of there,
Yeah.
go back in, hit matrix, and then calculate, and you're looking for RREF, R-R-E-F,
I didn't know it was still.
and then choose that as your matrix to do that with.
Wait, slow
Done.
down. How do you exit out?
Just
Second
wait.
quit.
Oh,
Did you get the same answer? After you
Yes.
frack it?
I will frack
You
it.
probably got 3.1 and 0.9.
Yeah.
No, sorry, oh, second.
9 over 10.
Okay, so we just figured out what A is.
where's that?
A is 31 tenths, and B is 9 tenths.
Correcto.
So we could rewrite our initial rational expression as,
Not worth it.
I'm going to go 31 over 10 x minus 7 plus 9 over 10 x plus 3.
Won't do it.
See what I did? It's a fraction, just put that on top, that on the bottom. And again, we're still integrating this. But at this point, what could we use for our antiderivative, Wilson?
Logarithm.
There you go. So we get 3/31 tenths natural log of x minus 7. plus c. Okay, so we rewrite it using partial fractions. That's the reason we learn partial fractions. It's for integration purposes.
No other reason.
At least there was one reason. Okay, so that's the most straightforward scenario where partial fractions, you have a nice factorable quadratic in the bottom, you go on from there. There are exceptions in partial fractions.
When you can't factor the bottom.
No, you should be able to factor.
Sorry. Chapter 6.
Take out that.
Alright, so again, we need to factor out the bottom. So the bottom factors to be
1.
x times x squared minus 1, right?
We can turn that to x.
Or negative 1.
So it's x times x plus 1, x minus 1.
That's easy.
That's our bottom. And I have x squared plus 2x plus 1 on top.
Ooh.
Does that actually factor?
Yeah, x plus 1.
Yeah, this isn't a very good example. Just get done saying that they're easy to make up.
And then Derek made fun of you for it.
Just told you.
Alright.
The answer, yeah, it was 1, 0, and
I
negative
can
1.
relate to this.
There.
Oh,
Oh,
had to do another try.
I think that's still factorable.
Sorry about that, viewers.
The answers are still 0 and 1.
Wait, what about x plus 2, x plus 2?
You're still gonna get 0 and 1 as
Alright, so the bottom factor is to be x squared times x minus 1, right? Okay, so one of our things in partial fractions, if you have a factor of multiplicity 2 or above, you have to assign an a for the x squared and an a for the x. So if it was x cubed, you would have to go a over x cubed plus b over x squared plus c over x. You have to work your way down. Remember that?
Yes.
Okay, so the x squared requires 1 for x squared and x, and then I have c for x minus 1.
Wait, have we done this in another class?
Last year.
I mean, not diamonding, like whatever you're doing with the letters.
Partial fractions, yes.
yes,
We
last
talked about
year.
that.
I wasn't
This
paying
class.
attention.
On
So
that
multiply both sides by this. I'll have x squared plus 2x plus 4 equals a times x minus 1 plus b x minus 1 plus c x squared. Right? So ax minus a plus bx squared minus bx plus c x squared.
Get my matrix warmed up here.